Welcome to Teja Statistics. Today we are learning about the semester number 3, which is a very important concept, that is uh, theory of estimation. What we are having in our theory of estimation? Let's see. In theory of estimation, we already have some definitions. They are the theory of estimation was introduced by R.A. Fisher, estimating the population parameters from observed sample values is nothing but a problem of estimation. And estimation can be classified as uh, two, that is interval estimation and point estimation. What is an interval estimation? The estimated value, the evaluation of a parameter of a population by computing on interval range of values. uh, this can be called as an interval estimation. Okay, here the estimated value points are lies between, okay, some limits. Okay, suppose mu is lies between 10 to 100, like that. The mean of the data of a set falls between 10 to 100, that is 10 less than mu less than 100, like that. Next, what is a point estimation? So here the process of finding an approximate value of some parameter of a population from random samples of the population is point estimation. The mean of the data set is 55, that is exactly mean value is 55. This is called the point estimation. Next, what is an estimate and estimator? A statistic which is defined on the sample values to estimate the population parameter is called estimator. The value of the estimator is known as estimate. Okay, so very simple and common definitions we are having, that is population, sample, sampling, parameter. Okay, and parameter, statistic, these are all. Here that statistic is said to be the estimator. It is denoted by T, and the unknown value of the distribution is known as the parameter value, which is denoted by theta. So what is parameter space? Here you can see set of all parameters of the population is called parameter space. It is denoted by here the H. Next, we can see the bias of an estimate. An estimate Tn, just now I explained what is T. T is a parameter estimated value. Okay, so the estimator what we are going to use, that is our Tn. Here an estimator is denoted by Tn, is said to be a biased estimator of T of theta. If the expected value of Tn is not equals to the T of theta, that is expected value of Tn is not equals to T of theta, then that is said to be the bias estimator. If it is equals to, then it is said to be unbiased estimator. Okay, we can see some more definitions over here, that is mean square error of an estimate. Okay, if there are more than one unbiased estimators, the problems arises which one choose out of this class of unbiased estimators. The sampling variance as well as the bias should be minimum. These problems are taken place with the help of uh, mean square error. What is a mean square error? MAC value, expected value of Tn minus uh, T of theta whole square. So that is biased square and plus variance of Tn MSE. Okay, you can see the formulas and definitions. Let's move on to the very important concept that is called criteria of a good estimator. Criteria of good estimator. The following are the four main characteristics to obtain the good estimator, also called criteria of good estimator. What is the criteria of good estimator? That is unbiasedness, consistency, efficiency and sufficiency. Let's see today about the unbiasedness. An estimator Tn. Here we have to write the capital Tn. So that is there. An estimator Tn is said to be an unbiased estimator of theta if it satisfies the condition expected value of Tn is equals to theta for all n belongs to the capital N, that is natural numbers, and theta is also be the parameter. Here it is greater than theta, then it is called the positively biased, and it is less than theta, then it is said to be negatively biased estimator. If it is not equals to theta, then it is called biased estimator. Just now we did. Let's see one example over here. That is, the sample mean x bar is an unbiased estimator of the population mean mu. That is, expected value of x bar equals to mu. The sample variance is biased estimator of population variance. Expected value of s square equals to sigma square. Like that we are having. Next, see the problem or theorem. We can say that the sample mean x bar is an unbiased estimator of the population mean mu. Let's see the proof. Let x1, x2, x3 and so on xn be a random samples of drawn from a normal population with xi follows the normal distribution with mu comma sigma square where I equals to 1 to n. Consider the sample mean x bar equals to 1 divided by n, summation I equals to 1 to n. So which you already know the formula. Apply expectation on both sides, then you will get the expected values. So mu1, mu2 and so on, that is I runs from 1 to mu I. If you remove that summation, then they are said to be 1 divided by n, that is mu. So here the sample mean x bar is an unbiased estimator of population mean mu in which distribution? That is in normal distribution. Similarly you can apply for the binomial distribution. Here xi follows binomial. X bar is an unbiased estimator of population mean np. Okay, see, x bar equals to same derivation. Okay, same calculation. You have x bar formula if you apply the expected value. So expected value of x bar equals to the formula expected value of x bar 1 by n summation xi divided by n. So the summation not applied to the constant, so putting outside 1 divided by n, summation remains the same and the expected value will be applied for xi. So what is the expected value of xi value? That is np. So 1 divided by n and gets cancelled, and what is the expected value of xi in binomial distribution? That is np. So here the x bar is an unbiased estimator of np. Okay, very simple. And similarly we can see in the Poisson distribution also the unbiased estimators we are finding out. So what are the unbiased estimators? You can see here. And similarly, S square formula for another calculation. Okay, we have lot of calculations. Okay, so simply to understand the unbiasedness of the condition, we have to see for four distributions they are uh, binomial, Poisson, exponential and normal. Okay, and here he may provide the what we can say the estimators, and he is going to ask you to calculate the which one is the best, and also he is going to ask you to find out the unbiased estimations. Okay, very simple and easiest condition is that to understanding about the unbiasedness, just remember this formula, that is called expected value of Tn is always is equals to the theta. This is your condition, very important condition. Please see, please remember here the Tn is said to be an estimator and theta is said to be the parameter. What it is? Parameter. Okay. In next class, we are going to see some more problems on this. Thank you.